So guys, today I will discuss about the grinding wheel. What is grinding wheel? These wheels are made of abrasive grain and held together by means of suitable binding material, that means called bond, and they are used in the machining operation known as grinding. Now, in previous class, I will already discussed about the abrasive. What is abrasive? There is two types abrasive. Number one, natural abrasive, and number two, artificial or manufactured abrasive. Natural abrasive, that means which are directly obtained from the mines. Example: diamonds abrasive, silicon abrasive, etc. Quartz abrasive. But the artificial abrasive, these are manufactured under a control of condition in closed electric furnace. Example: silicon carbide, aluminum oxide, and also artificial diamonds. Now today I will discuss about the bond material or bonds. What is bond? In order to give an effective and continuous cutting action, it is necessary that the grains of abrasive material should be held firmly together to form a series of cutting edges, and the material employed for holding them is known as bond. That means the abrasive which can hold between together by virtue of bonds, and these bonds are six types. Number one bonds is vitrified bonds. Number two is silicate bond. Number three, oxychloride. Number four, resonoid. Number five, shellac. And number six, rubber bond. These six types bonds we are so in produce a grinding wheel. First type is vitrified bond. What is vitrified bond? It is a clay bond and reddish brown in color. Its color is reddish brown color. The base material of vitrified bond is feldspar. Base material is feldspar. Feldspar. This feldspar is a fusible clay. That means it is a fire fusible. Proper properties of refraction and flux are added to it and mixed thoroughly. This mixture is together with the abrasive grain and is fed into a revolving drum containing water, where all the particles are mixed together to form a paste, and this provides a desired consistency to the mixture. The paste is then placed in molds to get the shape of wheel. That means wheel is round figure. This paste is mold together shape and to get the shape of a wheels, and then the wheels become enough hard. When it is cold, it is a hard. These wheels then fade into a kiln and allowed to remain there for a few days. In the inside temperature is more than 1260 degrees centigrade. This process is called fusing. This process is called fusing. This process is for obtaining the very hard and close grain wheels, the paste. After being placed in the molds, it is pressed under a hydraulic pressure, and rest of the process is same. What is the advantages of the vitrified bond? It is made porous and enable a quicker stock removal, and it is not affected by water, oil, acids, temperature. It is very important that if the wheels is affected by water or oil or acids, the wheel is damaged. In the grinding operation, this proper these types of affected material can be easily touched to the grinding wheel. And the bond next is the bond is itself very hard and acts as an also an abrasive. If the bond material is also an hard, abrasive also it is a properties is also an abrasive. Next is the structure of the wheel of the uniform due to weight mixing of the different continents. And what is the disadvantage? The process of manufacturing is very slow, and because if the in the 12 degrees centigrade this clay is processed for 3 or 4 days, this cause the process of manufacturing of vitrified bond is very slow. Number 2 disadvantage is the wheels crack may be developed in the large wheels. For when the wheels is very large, that means 750 degree dia, the wheel is crack. And so many disadvantage we saw in for vitrified bond. Next is silicate bond. What is silicate bond? Its base material is silicate soda. Silicate soda. The process of mixing, molding, packaging or ramming, drying, etc. are done in the same way for vitrified bond. But the oven is carries on a temperature about 260 degrees centigrade, which is much lower than the kiln temperature for vitrified bond. And the application of lower temperature result in a fairly high tensile strength. What is the advantage of silicate bond? First advantage is it is a more rapid process than vitrified bond, and because of the moderate temperature inside the kiln, there is no tendency to weakness the grain, and the fusing is better controlled and hence results in a more reliable bond. When we machine in the large wheel, that means 1500 millimeter dia can be easily produced by the silicate bond material. What is the disadvantage? Disadvantage is extra hard wheels cannot be produced with its bond. and harder grades of this bond do not provide a free cutting action. So many causes are occur for silicate bond. Okay, my next bond is oxychloride bond. Oxychloride bond. It is a mixture of oxide and chloride of magnesium which setting takes place in cold state. The process of wheel manufacture is similar to the above two, but not heating a subsequent cooling is required on account. Aging is there is the bond is provided a cool cutting action, but grinding is usually done dry as it is very susceptible to the action of convectional coolants. Full use of cutting capability of the wheel cannot be taken for oxychloride bond. Next one is resinoid bond. It is a synthetic organic compound which is enough strong and flexible. It provides a sharp cutting action and enables a high rate of stock removal at high speed. Resinite bonded wheels are mostly employed for cutting bars, stocks, and fine grinding of cans. These wheels are manufactured from a mixture of abrasive grain and synthetic resin and some compounds also. This mixture is filled in a molds and then fed into the furnace for heating. A constant temperature is 200 degrees centigrade is maintained to the furnace. We have seen that for silicate bond there is furnace temperature 260 degrees centigrade. Vitrified bond is very high temperature 1260 degrees centigrade, but for resinite bond there is only 200 degrees centigrade. Due to heat, the resin sets and binds the abrasive grains together, and the shape and size of the bonded wheels thus produced will depend upon the shape and size of the mold. Okay. Next one is shellac bond. What is shellac bond? Shellac bonds are produced by mixing the bond and the abrasive grains in a steam and heated mixer. Follow the molding under the pressure in the steam heated molds. These wheels are cool cutting and are vastly used on hardened tool steel than thin section. That is not very important for shellac bond, but next one is rubber bond. This is very important bond for a grinding wheel. It is composed a fairly hard vulcanized rubber. And the common manufacturing process consisting of passing of rubber and sulfur through the mixing rolls and then adding the abrasive grain slowly as the above two constitutions pass through a rolls. Wheels are then cut and the mixture is passed through the another set of roll to obtain the required thickness. Okay. The grinding wheels are then cut and placed in a preheated molds and vulcanized under the pressure. These wheels are quite strong, close grain, and can be made in very thin section. Okay. During the operation, the water can be safely used as a coolant, but caustic soda and oil should not be used, as the former distinguished the bond, while the latter softens it. Okay. Now we'll discuss about the symbolic represents of the bond. Symbolic representation of bond. Different types of bond used in grinding wheel. Now, first is for resinoid bond. Resinoid are two types. Synthetic resin. In the bracket we have write the synthetic resin, that is denoted by B, capital B. Now number 2 is also resinoid, reinforced. Also this is synthetic resin. Also this is denoted by capital B and F. Number 3 is vitrified bond. This is denoted by capital V. Number 4, oxychloride. This is denoted by O. Number 5 is shellac. This is E. And silicate. There is a silly mistake for shellac. Shellac is denoted by E, and silicate is denoted by S. There is also a rubber denoted by R, and rubber fabric reinforcement. This is denoted by RF. Okay, this 8 types of bonds with symbolic representation is very important. Now we will discuss about the grain or grit. The term grain or grit denotes the approximate size of the abrasive particle and gives him a idea of the constant fineness of the grinding wheel. A grinding wheel may have the abrasive particles of the same size or different size. The former is known as a straight wheel and the latter compound wheel. The choice of grain size or grits depends upon many factors. Okay. Now, the grit or grain size of the abrasive is denoted by a number representing and the number of meshes per inch of the screen through which the grains of crushed abrasive are passed for a grading. The standard number are that there was grit designation and there grain size or grit number or grit number. Okay. Now first is course. For course, their number is 10, 12, 14, 16, 20 and 24. Number 2 is medium. There is, for medium, the numbers are 30, 36, 46, 54, 60. And for fine, 80, 100, 120, 150 and 180. For very fine, the grit number is greater than the fine. That means 220 first, that means the 240, 280, 320, 400, 50, 500 and 600. These 4 types of grades designation we have get the grain size or grit number. Okay. Next is grade. What is grade? The term grade indicates the strength of bond in a wheel. That means the power of the abrasive particle to hold together and resist a disintegration under the cutting pressure. The higher the proportion of bonds for a specific quantity of abrasive particles, and the harder will be the wheel, and a lower proportion will under the its soft. In the for the different wheels, grades are represented by English alphabets from A to Z. A being the softness and Z is hardness. First, we draw the table. Okay. First, for the grade, soft grade, alphabet is A. A for, that means it is a softer grade, and when the grade is towards the Z, the grade is also hardest. Number 2 is B, C, D, E, F, G, H. Number 2 is medium. For medium grade, I, J, K, L, M, N, O, P. For hard, Q, R, S, T, U, V, W, X, Y and Z. Okay. Now we show the recommended ranges of grade and grid size for different operation. Now, for example, for high speed snaging, the grade is Q to R. That means the hard grade, the Q to R. And The grid size is this is grid. The grid size is, sorry, there is mistake. For high speed snaging there is Q to T, that means there to there, and the grid size is 16 to 24. In the previous table we see the grid size, that means 16 to 24. That means the grid designation is coarse grid designation, and the bond is resinoid. Similarly, for low speed snaging, the grade is Q to R. That means hard, but that is not vary for the distance. This is Q to R, and the grid size is 16 to 36. 16 to 36. That means coarse or medium. Coarse to medium is varies for low speed snatching, and the bond is vitrified bond. And another operations for another grade and another grid and another bond we get. Okay, today now stop. Okay, thank you.